Let's have a closer look at floor expansion today. Why do I want expansion? Which kind of expansions are there? And how do they get affected while the car is driving? First of all, if we look from the side, underbodies like we have in Formula 1 2022 have a curved profile. Together with the street, that creates a so-called Venturi tunnel. If you want to know more about how the 2022 F1 floors work specifically, check out my other video. Section A has a larger gap to the ground, Section B is closer, and Section C is further away from the ground. If we assume that the tunnel has the same width as every section, and the same amount of air flows through them, the same volume has to flow through the smaller Section B. That means that the speeds need to be higher. Higher speed, on the other hand, means lower pressure, and since this is happening underneath the car, it's sucking the car down, the so-called downforce. Now let's focus on sections B and C. Section C is what we know as diffuser. The diffuser is expanding the flow because it has a larger cross-section than in section B. What we are looking at here right now is the vertical expansion. Since the width of the tunnel is the same in every section, we can concentrate on the height. Let's use some numbers to understand what's happening here. Let's say we have a distance to the ground in section B of 70 mm and 300 mm in section C. That means that our expansion ratio is 4.3. This tells us, in the simplified example, that the air has 4.3 times less cross-section to flow in section B, or in other words, it needs to be 4.3 times faster in section B compared to section C. Now let's have a look at what happens if, for any reason, the car changes its ride height while driving. If we reduce ride height by 30 mm, we have 40 in section B and 270 in section C. The ratio is now 6.8, which is more than 50% more than before. That means that the flow in section B is now 6.8 times faster than before. That creates more downforce, but also makes the flow more sensitive to disruptions. If now, for any reason, the ride height goes 20 mm up from normal, we have 90 in section B and 320 in section C. The expansion ratio is now 3.5 and much lower than the 4.3 of our normal height. If we now add some steps and put it in a diagram, we can see how dramatically this ratio is changing the lower my car is above the ground. This is the reason why teams try to run cars as low as possible to get more downforce. And even if you just raise the car slightly, you lose lots of performance. But the risk here is also that if you run the car too low, the expansion ratio and hence the speed at the lowest point gets too high. It becomes very sensitive, and we shouldn't forget that there is also a boundary layer building up on the floor surface. The floor is a long part, so the boundary layer can be higher too. If this boundary layer is touching the ground, the floor can choke already, because high energy air cannot pass through anymore. So the floor doesn't even have to touch the ground to choke. If the floor suddenly loses downforce, the car will increase ride height rapidly, and you see how far that puts us back on expansion and hence downforce, until it sucks itself back onto the street. So you see that this vertical expansion is highly dependent on the car's ride height, because the road forms the second wall to create a Venturi tunnel. If the car body moves, the distance between floor and street changes, which in return can change downforce dramatically. So, in general, it's a good idea to have a smooth and gentle vertical expansion for a floor, to get a car which is easy to handle and without surprises. And now let's have a look at the other dimension, the horizontal expansion. Because we don't only have to think in vertical dimensions, we can also expand the cross-section of the floor in width. If we now think of a tunnel that has the same height in every section but different widths, we can also create an expansion ratio. Let's say at the narrowest point the tunnel is 80 mm wide and 480 at the widest point at the back. The expansion ratio is 6 in this example. If we now change the ride height, the expansion ratio doesn't change because both walls are part of the car. If we put this in our diagram, it looks like this. No matter what the ride height of the car is, the horizontal expansion stays the same. Of course, at a real floor, horizontal and vertical expansions always go together, but if we look at the current Formula 1 floors, it looks like Red Bull has a larger percentage of horizontal expansion and a very gentle vertical one. Ferrari and Mercedes did it the other way around. So I hope you liked this little insight and see you at the next video.